Now I know how to set a port as input or output, or a particular pin of a port as input or output. But how can I send that input or output data to a particular port? So now we will study how you can send a data to a particular output port. That means when a port or a pin is functioning as an output port, I have already said that port is taking data from your code. Then how you can write your code so that the code will send data to a particular output port. All right. So there is a particular way or particular instruction by which the output port takes data from your code. I have said about DDR. So when you are writing DDR, you are just declaring a port as input or output. You are not sending any data. So whenever you are writing DDR is equal to 0 and 8 ones or 7 1 or 6 ones, so that means you have declared it as output or input or whatever, but you have not sent any data to your port yet. So whenever you want to send a data, there is a particular instruction, and that instruction is you have to write the name of that port in capital letter. That means when for example I am sending data to port A, okay, and the data is like that. Again, for example, this is a microcontroller IC, and there are 8 pins of port A. It can be port B, C or D. All right. So now I want to send, and I have declared all the pins of this port A as output. So before starting the code, I have written this instruction 0xFF. So whenever I am writing this, the microcontroller or the compiler will understand that this port has been declared as the output port. All the pins of this port has been declared as the output pins or output port. Now I have to send data to this port. So whenever you are sending data to a particular pin, you have to send 1 from your code. So when I am sending 1, or that means a high bit, so you have already completed your digital electronics course. You know that there are high bits and low bits. High bit means 1 and low bit means 0. So whenever you are writing a 1 or a high bit to a particular port, so then what will happen to this port? When you are sending 1 to a particular pin or 2 pins or 3 pins, you are supplying 5 volt to a particular pin. That means, say I am writing port A is equal to 0B, then I am writing 1 1 1 1, then 0 0 0 0. That means I am sending 0 to the first 4 pins of port A. That means from PA0 to PA3 I am sending 0. That means I am sending nothing, and I am sending 4 ones to the highest 4 pins of port A. That means PA7 to PA4. So I am sending 1 to PA7 to PA4. Then from this one, what will microcontroller understand? So a microcontroller, whenever you are sending 1 to a particular pin, the microcontroller will understand that the code is instructing it to send a 5 volt to that pin. Now this is say PA4, this is PA5 and 6. Okay. So here you have sent 1. So after sending 1, now if you connect a voltmeter and you try to measure the voltage at this pin, then you will find that each of the 4 voltmeter will give a value of 5 volt. Okay. So by writing 1 to a particular pin, you are basically sending a 5 volt to a particular pin. So now if you connect an LED, say the rating of that LED is 5 volt. That means if you give a 5 volt across that LED will glow. Now if you connect an LED to any of these 4 pins, that means if you connect an 5 volt LED to any of the PA4 pins of PA4 to PA7, then if you send 1 to this pin, then that LED will glow. But look, I have sent 0 to the first 4 pins. That means I have sent nothing. So the microcontroller will raise a 0 volt to this pin. That means there will be a ground connected to this pin. Now if you connect an LED to this pin, that LED will not glow because it is connected to ground. So the LED is not getting power. So you have to keep this thing in mind, that whenever you are sending a 1 from your code, sending a 1 means that particular pin to which you are sending 1, that particular pin will get 5 volt from the microcontroller. Alright, so now let's have a look to this code. Here I am sending data to port C. So what instruction I am writing here? So I am declaring port C as the output register or output pin. So I have written that DDRC is equal to 0xFF. That means all the pins of port C, as it is FF, that means 8-1. That means 8 ones have been sent to the data direction register of port C. So all the pins of the port C have been declared as the output pin. So now I can send any data to port C, and I'm sending what? I'm sending port C is equal to 0x3b. So what is 3? We all know 3 means 0011 and B means 1011. So this is the binary form of 0x3b. So I am sending 1 to PC0, then PC1, then PC3, then this is PC4 and this is PC5. So if I connect a 5 volt LED to any of these 5 pins, then the LED will glow. But the other 3 pins to which I have sent 0, there will be a ground or 0 volt to this pin. So if I connect LED to any one of these 3 pins, the LED will not glow. So by this way you can send a data to a output port. So what you have to do, you have to write the port name, port A or B or C, and just you have to write the hexadecimal number. If you want to send a 5 volt, then you have to write 1. If you want to send nothing, that means 0, you have to write 0. So you can write any binary number or decimal number or hexadecimal number, whatever you want. Now I will show you 2 examples by which you will clearly understand what actually an output port does and how to declare a particular port of a microcontroller as output port. Now this is example 1. So example 1 says that you will be using port C of the ATmega32 or microcontroller, and 8 LEDs will be connected to the 8 pins of port C. So definitely this LED will operate at a voltage of 5 volt or less. So 8 number of LEDs will be connected to all the pins of port C. At first, only the MSB LED will glow. MSB LED means the LED that is connected to the MSB of port C. That means PC7 is the MSB of port C. So the LED that is connected to PC7 of the port C, so this LED will glow and others will remain off. Then after half second, the adjacent LED will glow. Adjacent LED means the adjacent LED of PC7 is the LED of PC6. So PC6 will glow and others will be off. And this shifting will continue up to the LSB LED. That means the LED of PC0, and this same movement will continue forever. So this term, this continue forever term is very important. So you have to write a code that will continue forever, unless and otherwise you are removing the power from ATmega32. So if you want a code to continue forever, you can write a loop. So if you have seen the video of C programming, then there were many kinds of loops: a for loop, while loop, do while loop. So you can use any of these 3 loops to write a code that will continue forever. We will be using a while loop here. So if you remember the syntax of while loop, after while there is a first bracket, and then there were a curly brace, and inside that curly brace the code has to be written, and within these parentheses you have to write the condition. That means if this condition is true, then the while loop will execute. If this condition is false, then the loop will not execute. So if you want a loop to execute forever, so you have to write a condition that is always true. We all know that any non-zero number is always true. So if I want a while loop to continue forever, then I just have to write a non-zero value or a true value here. Then I will write while 1. So the condition is 1 and 1 is always true, so the loop will continue forever. So if you ever face a situation where you have to continue a loop or a function forever, then you can write this type of code where the condition is a true number, while 1, and then you have to write your code within a curly brace. Okay, and then within this while loop you have to write the code to glow the LEDs. And how the LEDs will glow? They will glow by shifting. Okay, so LED will glow first, the other 7 LEDs will remain off, then another LED will glow, the other remaining will be off, and so on. So now if I look at this schematic diagram, so this is kind of, say this is the picture of ATmega32, and there are the 8 pins of port C, PC0 to PC7. So PC7 is the MSB LED. So this is the MSB LED. Okay. So at first this LED will glow and other 7 LEDs will be off. So at first you have to send a 1 to PC7 and you have to send all 0 to all these 7 pins, and then the adjacent LED to PC7 is PC6. So after half second this LED will be off and this LED will be on, and these 6 LEDs will be off. So after half second you have to send 1 to this pin, and the data you are sending to all other pins, that means this 6 pin and this pin will be 0. Then after half second you will send only 1 to this, and other you will send to other you will send 0, then 1 to this, and then 1, and then at last 1 will come to this LSB LED, and you have to send 0 to all other pins, and then again this MSB LED will glow, and then this sequence continues. Now how can I write this code? So I have already said that there are some particular syntax when you are writing a code in C, but in this lecture whatever I have covered, so you have to first declare the port C as output pin. That means you have to write DDRC, and you have to write some particular data in DDRC, and then you have to send data to port C. Now if I look at the Proteus diagram, as in this semester you are not having your lab associated with this theory course, so this Proteus will be very important, because you have to draw the overall schematic diagram in Proteus, and you have to write the code in C and then run them if you want to actually visualize the operation. So whatever you are learning from your theory course, you have to implement it using Proteus or CVAVR. So this will be the Proteus diagram of this simple code. So this is the ATmega32 chip. If you write the name of ATmega32 in your component list, then you will get it. This is ATmega32. This is PC0. This is port D. This is port B, and this is port A. So have a look. There are 8 LEDs. These black circles are 8 LEDs, and these 8 LEDs are connected to all the pins of port C. One side of all the LEDs are connected to ground, and the other sides, other 8 sides of the 8 LEDs are connected to the pin through a resistor. So through a particular resistance. So this resistance is used because this LED will not operate if a direct 5 volt is connected to the LED. So this resistance is connected to control the voltage and current that will be flowing through that LED. So if you do not connect this resistance, this Proteus diagram will not work. So now let's have a look at the code that you have to write. So this is the code snippet. So if you write just these lines in your CVAVR or C programming in .c file, then the Proteus diagram will work, and the LEDs will glow as you want from it. So first have a look that there are some slash. Okay, this is one slash, and this is the ending slash, opening and ending slash. So within the slash lines, some lines are written. The name of the file is ledshifting.c file. It was created on some date sometime. So these slash lines are actually basically the comment section. So if you write something within these 2 slashes, your compiler or your code will ignore these lines. Okay. So if you if you want to write something that will help you to clarify your code, or if you want to have a better understanding of your code, then you can write some explanation in your code. So you can write that explanation lines in a comment section. So if you write some lines in these 2 slashes, then the code will not care about these lines. It will not execute these lines. It will just bypass it. Okay. So you can write anything within these backslash lines. These are comment lines. The main code will start from here, this hash include line, and it will end here. So you have already familiar with the hash include line. So this actually the lines to include the header files. So whenever you are dealing with Atmega32 microcontroller, you have to include the header file of Atmega32, and that header file is mega32.h. So you have to include this header file, and also I am including another header file which is delay.h. So I have said that the in this code the LED will glow after 0.5 second. Okay, so after each 0.5 second the adjacent LED will glow and the sequence continues. So you are providing some delay here, some delay of 0.5 second. Okay, so whenever you are giving some delay to a microcontroller, you have to include this header file. The clock crystal frequency of Atmega32 is 16 megahertz. That means in 1 second the code is executed 16 mega times. So if you do not add any delay to your code, then you will not understand anything properly, because the code will be executed 16 mega times in a particular second. So if you want your code to function properly, that means if you want a 0.5 second delay between the glowing of LEDs, then you must include a delay time, and to include a delay time you must include a header file of delay which is delay.h. So whenever you are using any delay time, you have to include this header file, otherwise there will be an error in your compiler. So now there is a main function. Okay, so this is the main function, void main void. This is the opening curly brace of main function, and this is the closing curly brace of main function. If you miss any of these curly braces, there will be also error in your code. And then can you remember the instructions of this code? It is saying that the LEDs will glow sequentially. First of all, the MSB will glow, then the LED adjacent to MSB will glow, then the third one, then the fourth one, and in this sequence the LSB LED will glow, and then again the MSB LED will glow. So in one cycle 8 LEDs are glowing, and then I am coming back to the first LED. So here, and this sequence will continue forever. So I will be writing a for loop for that continuing forever function, and for the one cycle, that means 8 LEDs are glowing in one cycle, and then the cycle is starting from the first point. So I will be writing a for loop which will continue 8 times. So now for that for loop I have to declare a variable. We all know that for something is equal to 0, then some condition, and then some increment or decrement condition, for that variable will be shift, and I am declaring it as a char type variable. You can declare it as a int or whatever you want. So I am declaring it as a char type variable. So this will be an 8-bit variable, and that variable name is shift. You can use any name you like. So after the variable declaration, I am declaring the input or output mode of port C. So this is the input or output mode, DDRC, and I have already said that all the 8 pins of the port C will be output pins. So I am writing DDRC is equal to 0xFF. That means 8 ones are being sent to the DDRC. That means all the pins of the port C will be output. Now you have to keep one thing in mind, that whenever you are declaring a variable, you have to declare it at the first line of your main function. So if you just change this sequence, that means if I write DDRC just before the char shift line, it will show an error. So you have to first declare your variables, and then you have to declare the input or output mode of your ports. Alright, now I am starting my while loop. Okay, this is the this is the opening curly brace of while loop, and this is the closing curly brace of while loop. So these things, the lines, there are 4 lines, and these 4 lines will continue forever, as 1 is always true condition. So in first line I am writing port C is equal to 0x80. Now come to this figure. What is port X is equal to 0x80? Okay, port C is equal to 0x80. Now if I write it in binary form, then 8 means 1000, so 1, then 3 zeros, and 0 means 4 zeros. So I am sending just 1 to the MSB of port C, which is PC7. This was my function. I want the MSB LED to glow first, so I am writing 0x80. Then what will happen? Then after 0.5 second, I have to write 0, 1, 0, 0, then 0, 0, 0, 0. Then after another 0.5 second, I have to write this After another 5 seconds, I have to write 0001, 0000, and then the sequence will continue. So I do not have to write it several times because I have a function called a right shift or left shift, a shift operator. So if I use that shift operator, then this will perform this function. So what I'm doing here, I'm just all right, let's erase these things. Okay, now I have declared the port C as output, and I'm sending 1 or 5 volt to the MSB port of port C. So LED connected to this MSB pin will glow. Then I'm starting my for loop. This is the opening curly brace of for loop. This is the closing curly brace of the for loop. Then I am writing a delay. Look, delay underscore ms. Ms means millisecond. I have said that there will be delay of 0.5 seconds. So 0.5 second means 500 millisecond, because 1 second means 1000 milliseconds. So 0.5 second is 500 millisecond. So I am writing a delay of 500 millisecond. Then I am writing a semicolon after that line. There can be many delay instructions. There can be delay microsecond, but as I am giving just 0.5 seconds, so I am using delay millisecond. You can also use delay microsecond. So I am writing a delay function which will give a 0.5 second delay. Then at this delay time, the microcontroller will do nothing. It will just halt at this line for 0.5 second. Then after 0.5 second, it will come to this line. So what I'm writing here, port C equal to port C, then right shift 1. What will right shift do? Have a look here. Here the first number that I have written to port C was in binary form this thing. Then I am waiting for 0.5 second, then I am right shifting it. So what right shift will do? It will shift all the numbers to right for 1 bit. So the number will be, this 1 will come to here and a 0 will be put here. So the number will be this, okay. Then I will wait for another 5 second, 0.5 second, then I will right shift again for 1 value. Then this 1 will be shifted to the third position, okay, and then 0. And then in this way 1 will be shifted. And what will be my last part of the cycle? I want 1 to LSB, okay. So I want after 1 cycle the LSB LED will glow. So the instruction will be this, okay, 0B, then 40, and then 30 and 1. All right. So after how much cycle this will happen? After 8 cycles. So look at this code. Here I have written for shift equal to 0, then shift less than 8, then shift plus plus. That means this for loop will execute for 8 times. Shift is equal to 0, then shift will be plus plus, that means shift will be 1, then the loop will continue, then shift will be 2, then these instructions will execute, then shift will be 3 and 4, and then this for loop will continue up to shift equal to 7. When shift equal to 7, then after completing the executions, shift will be plus plus, that means shift will be 8. Now it will check the condition. If shift is less than 8, now shift is 8, which is not less than 8, so the for loop will not continue, it will break and it will come to this position, okay. So what actually is doing here, that is, you are first by this line you are sending 1 to the MSB LED, then you are entering into a for loop. This for loop is shifting the LED position. That means after this is PC7, then after this line PC6 will glow. Then say I'm just explaining one cycle of this for loop. Shift is equal to 0. So now the PC7 LED is glowing. Then shift equal to 0. This is less than 8. So the executions will continue. So here will be a delay of 0.5 second. Then there will be a right shift. So PC6 will glow now. PC7 will be off. Alright. So now the loop ends here. So it will come back to this here. Shift plus plus. That means shift was 0. Now it will be 1. Then it will check the condition if it is less than 8. Yes, 1 is less than 8. So it will enter into the for loop. Then there will be a 0.5 second delay. There will be a shifting then. Shifting means now PC5 will glow. then the end loop ends here, then again it will come to shift plus plus, then shift will be 2. Now it will check the condition if 2 is less than 8, yes 2 is less than 8, so it will enter into the loop, then again the loop continues. So the loop continues up to shift equal to 7. When shift equal to 7, PC0 will glow. So PC0 will glow, then after here PC0 will glow, then it will come to here shift plus plus. Shift plus plus means after shift equal to 7, shift will be 8, then it will check the condition if it is less than 8. No, it is not less than 8, so this for loop will not continue. Then this loop will break. Now it will come back to the first line of the code. So after 8 cycles here, the last LED is glowing, that means the LSB LED is glowing. Then again I am setting the MSB LED to glow. I am setting port C equal to 0x80. So after the LSB LED, that means PC0, I am setting again port C equal to 0x80. So I am setting PC7 equal to 1. Alright, so now at this time PC7, that means the MSB LED will glow, then again it will enter into the for loop, and this loop will continue forever.